Hello, welcome everybody. Let me give you the brief syllabus about this subject called as VLSI Design, which is in the 7th semester. And before going on to the module 1, let us have a look into the syllabus, which is as prescribed by the VTU University. And before that, we will be understanding about the objectives of this course. So basically at uh, the objective of this course for the student is to impart knowledge of MOS transistor theory and CMOS technology. So they will be understanding what is a MOS transistor and the details involved in MOS transistor along with CMOS technology, which is one of the families of the IC. They also have another objective of learning the operation principles and analysis of an inverter circuit, which is the basic circuit, which is the basic logic gate. And to begin with, any of the other gates, the concepts of inverters are dealt in detail, and that helps for the student to analyze the principles and analysis of different logic gates. So in detail, a study of inverter is dealt here. And the third objective is to design combinational, sequential and dynamic logic circuits as per the requirements. So different combinational circuits like the mux, parity generator, priority encoders, which are all combined together as a combinational circuit, and whatever is prescribed as per the syllabus, that particular concept will be analyzed here. And in sequential circuits also, basically which follows one after the other cascaded structure. So flip-flops and latches will be dealt in detail. And dynamic logic circuits, which involves the presence of capacitance and the clock circuit. So what are the different types of dynamic logic circuits, you will be understood. And the fourth objective is to infer the operation of semiconductor memory circuits. So for any operation to undergo, you need to have a storage area. So in an IC, you have to have an appropriate storage place, especially in MOS concepts. So what are the different types of memory circuits, and that too they should have a specialty in analyzing it as a semiconductor memory circuit. So basically we are dealing with semiconductors, so the different types of memory cells are understood. And finally the concepts of CMOS testing. So once the circuit is ready, end of the design, you have to test whether it is working properly or not, and therefore the concepts of theory, the procedure involved in theory of testing is dealt here. So this is how the objective is with respective to the subject VLSI design. So this is the first module where the brief history along with MOS transistor and CMOS is understood, and followed with the channel characteristics. What is a channel? What is a long channel? What are the non-ideal IV effects? These are all disturbing the ideal properties of the device. So what are those IV effects? How to overcome that, and how it will give us a difference in the working principles of the device. And along with that, DC transfer characteristics. Ideally a gate is taken here, and that gate is your inverter gate. So this is the brief theory which we are going to understand in module 1. In second module, after understanding the MOS theory, how to synthesize a device, that is nothing but fabrication. So before going into fabrication, it is very much necessary to understand layout and stick diagrams. So they go parallelly here. So we need to understand CMOS fabrication, only CMOS, which is a combination of NMOS and PMOS, and along with that the layout and what is the design flow and what are the different CMOS technologies, and along with that what are the design rules involved in designing or in conceptualizing the layout. So that is dealt here. And along with, whenever you're doing a VLSI design, it is shrinking in size or miniature structure has to be developed, therefore scaling has to be understood. So what is scaling in different contexts, and along with that what are the different geometrical effects due to scaling, what are the consequences after scaling, what happens if you shrink the size, what are those effects has to be dealt. And there's a separate topic which is called as MOSFET capacitances. Basically MOS is nothing but a layered structure, so the layer sometimes behaves as two layers, and two layers are conducting, and in between There may be another layer which behaves as an insulator. Therefore, the entire structure can be understood as a capacitor. Therefore, MOSFET capacitances has to be understood, and this happens in the second module. Next is the third module, which is concepts of delay has been understood. So what is the delay? The moment you give your input, what is the duration it takes to travel from the input to the output? That is normally called as a delay. And when you talk about delay, you also have to understand about transient response, RC delay model, linear delay model, logical efforts of paths. What are the different paths? All these concepts are understood here, along with combinational circuit design, which is about the different circuit families. Next we have the fourth module, which is all about sequential circuit design, as we have understood in the objective itself. So in sequential design, it is the concepts of basically latches and flip-flops. And in dynamic logic circuits, it is all about the pass transistor concepts, dynamic circuit and dynamic CMOS circuit techniques. So as I told you, there is a concept of capacitor and clock coming into this topic called as dynamic logic circuits. And finally, in the fifth module, we'll be understanding about semiconductor memories. So the different types of semiconductor memories are basically we have to read and write as well. It's not only read. Therefore, we are considering the RAM here. And we have two types of RAM, which is SRAM and DRAM, static RAM and dynamic RAM. And what are the different types of RAM cells has to be gone into understanding. And finally, we wind up with testing and verification. As I told you, at the end of the manufacturing, right from the scratch, right from understanding the MOSFET, then going into the fabrication, then coming up with the design concepts, then coming up with different logic gates, finally into and storing, you making use of the memories, and finally into testing. So in testing, how exactly is the procedure involved? Therefore, we understand in different topics like the logic verification principles and manufacturing test principles, and finally what is the necessity of need of our design. What is that topic called as design for testability. So this is how the syllabus is distributed as per the VTU experts who have come up with this syllabus framing, and that is what is dealt among the classrooms. So the outcome is, what is the outcome at the end of the course? So this is actually the students finally what do they derive from this subject. Demonstrate an understanding of MOS transistor theory, CMOS fabrication flow and technology scaling. So as I told you, MOS transistor theory, CMOS fabrication and along with scaling techniques. So in order to design, you need to understand about layout, right? To understand layout, it is very much necessary to talk about stick diagrams. So therefore, stick diagrams and layout diagrams with the knowledge of physical design aspects. It is combined together. That is going to be dealt here. And finally, demonstrate the ability. So student will be finally able to have the capability to design combinational circuits, sequential circuits and dynamic logic circuits as per the requirements. Basically, he will not go into the real-time problems, so he will have a rough idea of how the design goes on. So practicability will be finally understood once he starts working in an organization. So we make the student capable enough to design. So that is one of the outcome. And finally, interpret memory elements along with timing considerations. So you should be in a capability to tell what are the different memory elements, what are the different timing considerations, how you are going to keep in mind in order to design the memory elements. That has to be dealt, and end up with testing capabilities. So you should also have, you have to have some specialization finally. That specialization will be got only once you go out of the college. This is the limited knowledge which the university offers. With this knowledge, you will have a capability to expose yourself and explore much more deeper concepts. So the textbooks prescribed are CMOS Digital Integrated Circuits Analysis and Design, written by the Korean author Sung Mo Kang and Yusuf Lebli BC. So this is also a simple and a beautiful textbook which makes to understand CMOS in an easy go. And next you have Neil West and Harris textbook called as Circuits and System Perspective. This is also wonderful. So keeping these two textbooks, the entire concept is dealt in your classroom. And these are the reference textbooks, Cedra and Casey Smith, and Douglas Pucknell and Eshrian, and Razavi. So as and when the need arises, I'll just be referring which textbook I'll let you know. So these are the reference textbooks. So this is what we are going to talk about, which is module 1, and it is the brief history. So before going into the MOS transistor, we'll be talking about brief history, which is all about the concepts before MOS transistor.